Hello AP Statistics students. Welcome back to this edition of Free Response Tutorial. In this video we're going to take a look at 2018 number 2. Alright, looking at some sample surveys. So, what's our scenario? An environmental science teacher at a high school with a large population of students wants to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selected a random sample of students at the school to survey. Each student selected went into the teacher's office one at a time and was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval for the proportion of all students at the school who would respond yes to the question was calculated as that right there. All right, so first question, how many students were in the sample selected by the environmental science teacher? Woo! All right, this is actually quite an algebra heavy question. So we have to work backwards from this confidence interval to find the sample size. So your confidence interval, let's just do a quick review here, is your point estimator plus or minus the margin of error. So it's your point estimator, in this case our proportion, p hat, maybe I'll just put p hat there, plus or minus the margin of error in this case, because this is a proportion, all right, it's a one sample z interval. Our critical value is a z star times the standard error. All right, let's start putting a few numbers into this. What is the p hat? What is our sample proportion? Well, we got to do a little bit of math to find that. It's halfway between these two numbers, right? What's in the middle of the interval? So 0.584 plus 0.816, and then you divide that by 2. You find the average, essentially. And so our p hat is 0.7 plus or minus. Now, what's our z star? So for a 95% confidence interval, the z star is 1.96. You could probably get away with using 2 for this one and still get the right answer, but to be more precise, it's 1.96 times the standard error. Now, what is the standard error? It is the square root. Now, if you don't remember this formula, it's definitely in your formula sheet. You would find the standard error for a one proportion sampling distribution. But it is P times Q divided by N. So now time for some algebra, because we are looking to solve for N, aren't we? So what we're going to do is we're going to take the margin of error. This whole piece right here is the margin of error. That's how much you're adding and subtracting. Well, how much are we adding and subtracting? Well, the middle is 0.7. So we did 0.7, and I can either add or subtract to figure out what the distance is. I'll go to 0.584. How far is it from 0.7 to 0.584? So my margin of error was 0.116. So 0.116 is equal to 1.96 times the square root. Oh, PQ. We know what P is. P is 0.7. That is our sample proportion. That means Q is 0.3 divided by N. Hey, look, we now have ourselves an algebra equation with only one variable, which means we can solve this. I want to do a few steps in one here because that's not too hard. First, get rid of the 1.96. which means I have to divide 0.116 by 1.96. All right, now I want to get rid of the square root. How do I get rid of the square root? We square both sides. So I'm going to square both sides. So I'm left with 0.0035 is equal to, we just got rid of the 0.96 and we got rid of the square root. So we have 0.7 times 0.3 divided by n. All right, get n by itself. Probably the easiest way here is to cross multiply. So we have 0.7 times 0.3 is equal to 0.0035 times n. Divide both sides, and we will get n by itself. So 0.7 times 0.3 divided by 0.0035. That's probably enough decimal places because the next one's a 0. So that'll give me enough accuracy, I think. And we get n equals 60. So they asked approximately 60 students here. Looks good, looks good. All right, let's move on here. Part B. Given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how the bias might affect the point estimate of the proportion of all students at the school who would respond yes to the question. So what was wrong with this environmental science teacher's method? Well, let's go back up and take a look at his method. Let's see. They took a random sample. That's pretty good. But, oh, here it is. Each selected student went into the teacher's office one at a time. You're in that room one-on-one with the environmental science teacher, and the environmental science teacher asks you, hey, do you recycle? There's a good chance that you might lie if the answer truthfully was no. So, because students are in the office alone with the environmental science teacher, they might be less likely to respond no, even if they don't recycle. All right, there is our bias. Now, I'm still missing one thing with this answer. All right, I've said what might happen, not how it will affect the point estimator. This would you could either say overestimate or underestimate depending on which one you're describing. I'm going to say this would overestimate the proportion of students who would respond yes to the question. All right, probably safer to go that route. It would overestimate the yes because that's what they asked about in the problem right here. The proportion they're asking you to comment on is the proportion that would say yes. So that would overestimate the proportion of students who would respond yes. All right, part C. Ooh, that looks long. All right, let's do some reading. The statistics teacher at the high school was concerned about the potential bias in the survey. Good for them. To obtain a potentially less biased estimate of the proportion, the stats teacher used an alternate method for collecting student responses. A random sample of 300 students was selected, and each student was given the following instructions on how to respond to the question. In private, flip a fair coin. All right. If heads, you must respond no, regardless of whether you recycle regularly. If tails, please truthfully respond yes or no. Do you see how that helps? Now someone could feel free to respond no because maybe it was just a coin flip. It gives people freedom to say no. Interesting. All right, what is the expected number of students from the sample of 300 who would be required to say no because of the coin flip? Oh, well, that's not too bad, right? That's just n times p, right? There were 300 people in the sample, and a coin flip's 50-50 if it's a fair coin flip. So half of them would be required. We expect. Now, would it be off a little bit? Yes, but we would expect half of them to have to respond no because of the coin flip. All right, let's keep going. The results of the sample showed that 213 of the 300 selected students responded no. Based on the results of the sample, give a point estimate for the proportion of all students at the high school who would respond yes to the question. So what is the actual proportion of people that recycle? Well, we have 213 people that said no, but 150 of them were required. We expect 150 of them were required to say no. So that means we actually only have 63 real no votes. At least that's what we expect from our sample here, that 63 of them are actual no responses. All right. Well, how many actual yes responses do we have? Well, we only have 150 real responses, right? Because 150 of them were the fake no's. So there's 150 real responses. And if we expect 63 of those to be the no, then the rest would have to be the yes. So 150 minus 63 is what? 87? So our proportion is 87 out of 150. So that is our point estimate for the true proportion of the students at the high school who would respond yes to whether or not they recycle regularly. All right, I hope that makes some sense to you all.